You are listening to The Vocal Technologist. Spoken tech for your ears.
So to really kick off this deep dive, we kind of have to go all the way back to 1769.
Oh, right, the steam engine.
Exactly. So in 1769, James Watt patents this totally new kind of steam engine. And up until that exact point, steam engines were just incredibly inefficient.
Yeah, they were basically just burning massive amounts of coal just to pump water out of mines.
Right. But then Watt figures out a way to add this separate condenser, which fundamentally changes the thermal efficiency of the whole machine. I mean, suddenly it requires vastly less coal to do the exact same amount of work.
Which is a huge breakthrough.
It is, but here's the thing. If you look at that purely logically, you would assume British coal consumption plummeted over the next few decades, right? Because your inputs are suddenly cheaper and way more efficient.
But that is definitely not what happened.
Yeah. No. British coal consumption actually exploded. It rose like tenfold over the next century. And the reason I'm bringing this up is because today we are looking at this massive stack of recent research, startup strategies, tech analyses, and our mission for this deep dive is to figure out what actually holds value in the AI era for you, the listener.
Yeah.
And to understand what happens when AI completely commoditizes human knowledge, we kind of have to start with why James Watt accidentally caused a coal shortage.
Yeah.
So, welcome to the deep dive.
It really is the perfect historical parallel for the anxiety everyone is feeling right now about automation. Because what you're describing with James Watt is called the Jevons paradox.
Right.
And it basically states that when a technological advancement makes a resource cheaper and more efficient to use, it doesn't reduce demand for that resource. It actually drives demand through the roof.
Because suddenly everyone can afford to use it.
Exactly. Because energy became so cheap, engineers and entrepreneurs suddenly found exponentially more use cases for it. You know, trains, factories, mills, entire industries were born purely because the underlying energy costs just collapsed.
Okay, let's unpack this. Because if we map that onto the AI era, we're looking at the exact same economic mechanism, just with a different underlying resource, right?
Yes. Our sources call this the AI knowledge paradox.
Right. So the cost of finding, translating, summarizing, and synthesizing information is basically collapsing to zero. But the demand for knowledge work isn't disappearing at all.
No, the demand is exploding. The Jevons paradox basically guarantees it.
What's fascinating here is that the critical distinction, the thing you have to pay attention to, is that the bottleneck in the system has shifted.
How so?
Well, for the last 30 years, the bottleneck was access and synthesis. Like if you could quickly gather 100 pages of market research, synthesize it into a clean 10-page report, and present it clearly to your boss, you were highly valuable.
Oh, absolutely. Your ability to process that information was your moat. Exactly. But AI completely destroys that moat. Synthesis is now just a free commodity.
But wait, if an LLM can instantly synthesize that 100-page report, and it can even generate recommendations based on it, why do we need human insight at all?
That's the big fear. Right.
Yeah. I mean, if the machine does the gathering, the summarizing, and the predicting, the demand for the human doing the synthesis drops to zero, doesn't it?
The demand for the human doing rote synthesis drops to zero, yes. But the new bottleneck becomes what you actually do with that synthesized material.
Okay.
The new moat is insight. It's taste. It's your ability to produce something genuinely novel out of this massive sea of suddenly cheap material.
So it's like the invention of the calculator.
Yes, exactly.
Like it didn't eliminate mathematicians, it just let the curious ones do much harder math much faster.
That is a great way to put it. The documents we're analyzing make a very blunt point about this. AI does not automatically make an average worker great at their job. No. What it actually does is drastically widen the gap between the people who are already highly capable and everyone else.
Okay, but give me a practical example of how that mechanism works in the real world. Why does it widen the gap instead of, just leveling the playing field for everybody?
Think about client context. So an AI agent might be able to instantly generate a flawless, grammatically perfect proposal for a major enterprise client. A junior employee can just prompt the AI and get that document in 10 seconds.
Right, which sounds great on paper.
But the AI doesn't know the internal political dynamics of that client's procurement team.
Oh.
It doesn't know that the chief information officer is highly risk-averse and, secretly prefers conservative vendor lock-in over cutting-edge open-source tools.
Right, the machine has no idea who these people actually are.
Exactly. But the highly capable, curious worker knows that context. They take the cheap synthesized output of the AI and they mold it, they edit it, and direct it using deep, nuanced human reality.
That makes a lot of sense. So this displacement narrative we hear so often, the idea that a faceless AI agent is going to just take your job, it kind of misses the mark.
It completely misses the mark. You won't be displaced by an AI. You are going to be displaced by another human being who treats AI like a lever.
Applying their own deep technical curiosity and real-world context to move much heavier objects.
Exactly. And if human value is shifting radically away from rote information processing and moving entirely toward applied contextual logic, well, the tools those humans use have to undergo the exact same structural evolution.
Yeah, specifically enterprise software. Because if the human moat is shifting, the software moat has to shift.
Precisely.
Because right now, the primary interface we use to interact with computers is changing.
Yeah.
We aren't navigating complex drop-down menus as much anymore. We're just typing plain English into a chat box.
Right.
So if the interface is just a conversational agent, where does a software company's value actually live? The sources talk a lot about this concept, the idea that software is, quote, losing its head.
It is a massive architectural shift. I mean, look at industry giants like Salesforce. They are aggressively repositioning themselves around headless APIs.
Headless meaning no traditional user interface.
Exactly. For decades, a software company's defensibility, its moat, was its user interface. If you had the most intuitive dashboard, the slickest mobile app, the stickiest front-end experience, you dominated the market.
Your users literally lived inside your head.
Right, but in an era where AI agents do all the navigating for us, those human-facing UI modes are eroding incredibly fast.
But wait, if I'm an enterprise buyer and I can't really see or feel the UI anymore because my team is just interacting with a unified chat assistant that plugs into a dozen different tools, why am I paying premium enterprise prices for those underlying tools?
That's a fair question.
Right, because if everyone is eventually just connecting via APIs to the exact same foundational LLMs, aren't we just commoditizing software? It sounds like a race to the bottom to me.
Well, if we connect this to the bigger picture, it would be a race to the bottom if software were only a user interface. Think of it like an automobile. The dashboard, the steering wheel, the leather seats, that's the UI.
Chassis.
Yeah, the chassis. And for a long time, companies competed on having the most comfortable chassis. But headless software means you are no longer selling the chassis, you're selling the engine block.
Oh, interesting.
You can drop that engine into a sports car, a truck, or a minivan, or in this case, a Slack integration, a voice assistant, or a custom internal dashboard. The defensibility moves deeper into the invisible layers of the stack.
So what exactly is inside that engine block that makes it so valuable?
Yeah.
Because it can't just be a basic database anymore.
No, definitely not. The venture capital firm A16 Assets describes this as the evolution from systems of record to systems of intelligence.
Okay.
A system of record is passive. It just holds your data. But a system of intelligence is an active orchestration layer. The moat becomes the complex data models, the highly intricate permission structures, the robust compliance logic, and flawlessly reliable execution.
So it's basically the underlying nervous system that tells the AI agent exactly what it is legally and operationally allowed to do with a company's proprietary data.
Exactly.
Okay, let's look at some of the specific platforms doing this, like Lightfield CRM, right?
Yes.
They have this new skills feature where the AI actually learns workflows that you just described to it in plain English.
That's a perfect example. And then there's Linear. They just introduced a feature called Code Intelligence.
Right, and Linear is a project management tool for software teams. But this feature fundamentally changes how the tool operates. They aren't just storing task tickets anymore.
No. They are giving an AI agent highly secure, read-only access to a company's actual living code base.
Which is wild.
It is. And the mechanism there is crucial to understand. Historically, knowledge in a software company is heavily siloed. If an account executive needs to know why a specific enterprise feature is delayed, they usually have to ping a developer on Slack.
Right, totally interrupting their flow state just to translate a technical blocker into business terms.
Exactly. But by giving the Linear agent access to the raw code repository, the AI can actually reason about how the product fundamentally works. It reads the commit history, it understands the dependencies, and it turns raw code into shared product context that a non-engineer can just query in plain English.
That is insane. And we're seeing this across the board, right? Like Notion's new developer platform for agent tools is doing very similar things.
Yes, turning a workspace into a true system of intelligence.
But the computing power required to do that must be astronomical. I mean, if you have an AI agent reading an entire code base and synthesizing complex dependency trees every single time a product manager asks a question, how do you even run that infrastructure?
You definitely can't run dynamic agentic workflows like that on clunky legacy servers.
Right.
You absolutely can't, which is exactly why the infrastructure layer is radically shifting to support these headless applications. When you build AI features that hit heavy production traffic, the engineering team almost immediately hits a wall.
Because of the server costs.
Costs and
Yeah.
management. They have to stop building the actual product and start managing infrastructure. Provisioning GPU nodes, handling load balancing, dealing with cold starts, and wrestling with massive vendor contracts.
Okay, and a cold start is when a server isn't actively running to save money, right?
Yeah.
So when a user sends a prompt, there's this huge delay while the server boots up.
Exactly. And that latency just destroys the user experience. You can't have a conversational agent that takes 30 seconds to reply.
Yeah, that completely breaks the illusion.
Which is why our sources highlight the rapid adoption of serverless infrastructure, specifically pointing to tools like DigitalOcean's Serverless Inference API.
I want to dig into how this serverless inference API fundamentally solves that bottleneck, because the benchmark statistics in these reports are just wild.
They really are. So the mechanism of serverless inference is that it completely abstracts away the hardware layer for the developer. You aren't renting a server or committing to a massive multi-year GPU contract.
Okay.
It just operates as an OpenAI and Anthropic-compatible API endpoint. You point your application to it, and you have instant access to over 55 open source and frontier models, including Claude, Llama, and Quinn.
And because it's serverless, you only pay per token.
Right.
So if nobody is querying your system of intelligence at 3.0 a.m., the infrastructure scales all the way down to 0. You pay absolutely nothing.
Yep.
But then when 1,000 employees log on at 9:0 a.m., it instantly scales up without hitting those terrible cold start delays.
Exactly. The raw performance completely removes the DevOps penalty for building these AI tools. Independent tracking by artificial analysis actually just ranked DigitalOcean's API as #1 for output speed when running DeepSeek v3.2. Yeah. It is currently operating 3.9 times faster than AWS Bedrock.
That's a huge difference.
It is. That sheer frictionless speed is what allows these complex headless orchestration layers to function in real time without bankrupting the startup building them.
Here's where it gets really interesting, though,
Right.
because this brings up a massive conceptual hurdle.
Okay.
We have an API engine block that acts as a system of intelligence. And we have serverless infrastructure that scales infinitely and runs blazingly fast.
Right.
Technically speaking, any competent engineering team can spin that up over a weekend now.
Yes, they can. So how do you actually figure out what the engine should do? If the user interface is gone and you can't just stare at a dashboard to see how users are clicking around, how do you build a defensible product?
This raises an important question for anyone building in this space, because the universal consensus across the strategic memos we are reviewing is that you have to get out of the building. Field work is the ultimate new moat.
Fieldwork. Yes. Deploying enterprise AI efficiently requires a profound, granular understanding of how a specific company actually operates in the real world. You cannot build these systems from a high-rise office in Silicon Valley.
Right, which is why we're seeing the rise of a very specific engineering role to solve this, the forward deployed engineer, or FDE.
Exactly.
And these aren't software developers sitting in a vacuum writing clean code. They are quite literally out in the field, embedding themselves with the client's teams, observing the messy, highly irrational human reality of their daily workflows.
Because if you don't embed with the client, you have to rely on standard product metrics to guide your development. And right now, standard metrics are deeply dangerous. The research warns heavily against reductionist thinking.
Okay, define reductionist thinking in this context.
The core idea is that simplicity is seductive, but simplicity is not the same thing as truth.
But wait, metrics are how we scale businesses. Like, if I launch an AI agent and I hit my daily active user targets and my top-line revenue is growing month over month, that empirically means the product is working and delivering value, doesn't it?
Not in the AI era. Let's look at a hypothetical scenario to understand how reductionist metrics lie to you. Say you build an AI that auto-replies to a company's customer support tickets.
Okay.
You deploy it, and your metric tickets closed per hour absolutely skyrockets. The dashboard looks incredible.
So far, so good.
But what the metric doesn't show is that customer satisfaction is plummeting, because the AI is aggressively and politely refusing to issue legitimate refunds, leading to a massive spike in customer churn.
Oh, wow.
And that churn won't show up in your revenue data for another 3 months. You might hit your revenue target today, but it is bad revenue.
It's bad revenue because it's built on a hollow interaction that damages the long-term relationship. I mean, the AI optimized for the exact metric you gave it, closing tickets, but it lacked the human context of retaining loyalty.
Precisely. Every clean metric has a domain where it works beautifully and a domain where it breaks down entirely. The forward-deployed engineer sits in the call center, watches the AI deny the refund, sees the customer get angry, and immediately patches the system's logic. You cannot capture that failure state from a dashboard.
I love the analogy in the sources about navigating a magnetic storm.
Oh, yes.
Like, metrics are like a compass. Under normal conditions, a compass is essential.
Yeah.
But if you're navigating a massive magnetic storm, which is exactly what this current AI boom is,
Yeah.
the compass is going to spin wildly out of control.
Right.
If you just stare at the dial, you will crash. You have to look out the window and navigate by the terrain. That's what fieldwork is. It's looking out the window.
And it requires actively stress testing your own assumptions. The tactics recommended here for avoiding reductionist thinking are really rigorous.
What do they suggest?
Before you bet your company's runway on a single metric, you have to find exactly where that metric breaks. You need to run two entirely different, contradictory mental models simultaneously. You basically have to think probabilistically, assigning confidence scores to your ideas rather than treating them as absolute truths.
There's a fantastic line in one of the essays about how speed is sometimes just impatience disguised as ambition.
Yes.
Like, you rush a slick AI-generated product out the door because it looks good on paper and it was incredibly fast to code. But it fails completely in the enterprise market because you skipped the grueling, unglamorous fieldwork of understanding the customer's actual context. It's the fast lane to mediocrity.
And the market is ruthlessly efficient at sniffing out products that lack that foundational fieldwork. We actually have a piece of very blunt advice in our stack from Eogan.
Oh, the VC advice.
Yeah. He states that if 100 venture capitalists look at your idea and reject it, you shouldn't assume you were a misunderstood genius. You might just be entirely wrong. You probably haven't done the work to map your technology to a real, painful human problem.
So what does this all mean? Let's play this out. Let's say you survived the crucible. You've avoided reductionist thinking. You have embedded your engineers with the client. You've done the messy field work. And you have built a true headless system of intelligence powered by serverless infrastructure.
Okay.
And it works perfectly.
Yeah.
You still have a massive existential problem. How do you get anyone to buy it in a market that is flooded with thousands of infinite cheap AI startups launching every single day?
You have to control the narrative.
Yeah.
If you build the best engine in the world, but you don't tell a compelling story about it, you will be ignored. The strategic advice we are analyzing is highly prescriptive here. Founders must spend 20% of their time making their startup look inevitable in public.
Inevitable.
Yes, because if you do not project that inevitability and completely own your narrative, a louder, potentially inferior competitor will gladly take up that space.
But who are we projecting this inevitability to? Like, are we marketing to human buyers or are we marketing to the AI itself? Because the sources discuss this wild concept of optimizing for artificial audiences.
It is a hybrid approach, and it is a fascinating technical challenge. We are seeing platforms like Lovable building deep discoverability tools directly into the application creation process.
Right, like structuring apps so they can be read.
Exactly. Historically, you optimized a website so that Google search crawlers could find your keywords. But AI discoverability, essentially AI SEO, requires a totally different structure.
How does an LLM reading a site actually differ from a traditional Google search crawler?
Well, a traditional search engine crawler looks for keyword density, backlinks, and basic site hierarchy just to serve up a list of blue links to a human.
Right.
An LLM, on the other hand, is scraping the web to directly answer a user's prompt natively within the chat interface. So Lovable runs comprehensive reviews of a startup's sitemaps, robots.txt files, structured metadata, and deeply nested content architecture.
So it's making sure the AI agent can ingest the actual logic and utility of the app, not just the marketing copy.
Exactly. You are structuring the app so the AI can read it, understand its capabilities, and recommend it autonomously to an enterprise user.
It is such a strange paradox. I mean, we are using AI to write the code base. We are deploying headless AI orchestration layers via serverless APIs, and then we are optimizing our metadata so that other AI agents can discover our product.
It's just machines talking to machines.
Yeah. Where does the human even fit into this go-to-market motion?
The human fits in because at the very end of that complex, automated chain, a human still has to sign the check.
True.
And the ultimate secret to breaking through the noise of all this AI-generated perfection is raw, unpolished, human authenticity. The final piece of source material we have is literally a self-filming guide for technical founders.
Yes, I love this part.
Right now, the most successful enterprise startups aren't hiring massive creative agencies to shoot cinematic commercials. The founders are shooting their own product demos and launch videos on their iPhones.
And the technical advice in this guide isn't about buying, a $10,000 RED camera. The ultimate secret to a perfect demo video that actually converts viewers into buyers is literally a $100 lavalier microphone.
It comes down to psychoacoustics. The human ear is incredibly sensitive to audio fidelity. If you shoot a video with a slightly blurry webcam, viewers will forgive it. They process it as scrappy or authentic.
Right, it feels real.
But if the audio has a slight echo, or if it sounds like you are speaking in a tin can, it creates immediate subconscious cognitive load for the listener. The brain just has to work harder to decipher the words.
And the second the brain has to work harder, the viewer clicks away.
Yeah.
You absolutely cannot fix bad room audio in post-production. It ruins the perception of your competence, no matter how brilliant your underlying code base is.
Precisely. And the visual advice is equally grounded in basic physics rather than expensive gear. The guide stresses not to buy complex studio lighting rigs. You just find a large window and you position yourself so you are sitting on the shadow side of it.
Right, allowing the natural light to just wrap around your face.
Exactly. It provides perfect high-contrast cinematic lighting basically for free. And the golden rule they mention, always do a 10-second audio test before you record the full 30-minute take.
That perfectly encapsulates the absurdity and the beauty of where we are right now.
Mhm.
I mean, you're building the most sophisticated agentic technology in human history. You are leveraging serverless inference APIs and complex metadata structures.
Mhm.
But your commercial success still completely hinges on remembering to clip a $100 microphone to your shirt and sitting next to a window so your voice sounds clear enough to tell a good story.
Because rote knowledge and code are now free commodities. Raw human authenticity, real-world context, and high-quality storytelling are the ultimate premium assets. They're the only things an LLM cannot easily replicate.
So let's just trace the causal chain we built today for you. We started in 1769 with the Jevons paradox, understanding that as AI makes the synthesis of information incredibly cheap, the demand for true contextual human insight becomes infinitely more valuable. We saw how that shifts the structure of software itself, moving away from user interfaces and transforming into headless systems of intelligence powered by frictionless, serverless inference APIs. We learned that the only way to build the logic for those invisible systems is through rigorous fieldwork, avoiding the reductionist metrics that look great on a dashboard but destroy a company in the real world.
Right.
And finally, we saw that even the most advanced systems still require the scrappy, highly human art of narrative and perfect audio fidelity to actually reach the market.
It is a profound shift in how we build and value technology. But as we wrap up, I want to leave you with one final, slightly provocative thought to mull over.
Okay, what is it?
Well, we talked about how applications are increasingly being structured and optimized for AI discoverability. Metadata explicitly designed for non-human eyes.
Yeah, the AI SEO.
Right. So if we follow that trajectory and AI agents eventually take over not just the creation of software, but the actual evaluation and purchasing of software for enterprise companies, will there come a point where human-facing marketing doesn't matter at all?
Oh, wow. Imagine a future where your startup's entire narrative motion is just your AI agent aggressively negotiating features and pricing with a client's AI agent in milliseconds. What does a brand or a compelling story even mean in a world of purely machine-to-machine commerce?
That is a wild, slightly terrifying thought to end on. If the machines are doing the buying, maybe the window lighting won't matter so much after all. Thank you so much for joining us on this deep dive. Keep questioning the clean metrics, do the messy field work, and keep your curiosity sharp. We'll catch you next time.
Spoken Tech for your ears.